Hello Year 2 and welcome to another maths lesson. Well done on finishing your Power Maths book. That's excellent that you've got all the way through. For the last few lessons we are just going to focus on some of the things that we've already learned in Year 2 to keep them nice and fresh in our brains for over summer and for when we come back in September. Now today we're going to be looking at bar models and we're going to be looking at how you can use them to help you solve problems. Okay, so we're going to start off with a Flashback 4 as usual. You're going to need a pencil today, a piece of paper, a plain piece of paper will be fine, and if you've got one, a ruler would be really helpful too. So go and get one of those, and when you're ready, we'll move on and we'll do the Flashback 4.
Okay, here's today's Flashback 4, so have a go at these questions. Click pause here and click play when you're done. Right, let's go through these answers then. Question 1, what is 2 times 8? And the answer is 16. Question 2, there are 5 flowers in each vase. How many flowers altogether? Well, if you count up in fives, 5, 10, 15, 20 altogether. Question 3, complete the sequence. 2, 4, 6. Well, we're counting up in 2, so next we've got 8 and then 10. And finally, find the sum of 3, 4 and 7. Now you could have done this in a number of different ways, but the quickest way would be to notice that 3 and 7 are a number bond to 10, and 10 add 4 more makes 14. Okay, let's have a look at today's new learning then.
Okay, so today we're talking about bar models. I'm going to start off talking about what bar models look like, reminding you how you can use them, and giving you a few examples of the types of questions you might have, and then I'm going to give you a few questions to have a go at yourself. So let's talk about bar models. You can see here that I've got a fully completed bar model. I've got 10 at the top and 6 and 4. And this is showing me that 10 is my whole and that it's made up of a 6 and a 4. These are the parts which are making it up. And the great thing about a bar model is that as well as using the numbers to show us that, we can see that the bars are showing us that as well. The biggest bar is 10, and you can see the 2 smaller bars that are the same when they're added together, but make up the 2 parts when they're separate. And from this bar model, we can get some calculations. We could say that 6 and 4 make 10, 4 add 6 make 10, or we could think about some subtractions. 10 take away the 6 would leave us with just the 4 part, and 10 take away the 4 part would leave us with just the 6 part. So this is a really basic bar model, and it's just there to remind you of how a bar model works. But let's think about some slightly more complicated examples and think about how we can use this when we're solving problems. Let's take this question. Manny is working at home. She spends 11 minutes on phonics, 21 minutes on maths fluency, and 38 minutes on English. How long does she spend working altogether? Now this has got quite a lot of words in this question, and it would be easy to read it and go, oh, there's lots of numbers in here, what do I need to do? But if we break it down step by step and represent it with a bar model, that means show it with a bar model, then it becomes a lot easier to answer. We need to work out how long she's been working altogether. And we can see that there are 3 parts here. 11 minutes for phonics, 21 minutes for maths fluency, and 38 minutes for English. And I've represented that here. 11 minutes, that's the smallest part, 21 minutes, and 38 minutes. Now, I might want to go away now and add these up with the column method, or add them up with a different method. But showing it like this helps me see really clearly what I'm trying to do. I've got 3 parts, and I need to know how much they are all together. And you might even want to add 2 of the parts at a time. So for example, I might decide that I want to add 11 and 21 first, and that will give me 32. So I've worked out this bit, and now I just need to add it on to 38. So now I've got a much more simple sum. I've only got 2 numbers, 32, and then add 38, this part here. And we'll see that when we do that, we get 70. So this is just a really nice way of representing the problem and helping you think about the steps you're going to use to answer it. Let's have a look at another example. This question says this: there are 57 counters in a bag, 37 are red and the rest are green. How many green counters are there? Now again, the bar model is a really good way of representing this, helping you think about what is happening in the problem. So here you can see that altogether I've got 57, haven't I? I've got 57 counters in that bag. And I know that 37 of them are red. So this is one part, it's not the same as the whole. There's a bit missing, and that's the green counters. So it's my job to work out what this missing bit is to get us from 37 all the way up to 57. Now there's a few different ways you could think about this. You could do 57, take away the 37 part, would just leave you with this one. Or you could count on from 37. 37 add what will get me to 57. And if you've spotted that both numbers have 7 in the ones, then you'll know that you just need to count up in tens. 37, 47, 57. So we've added 2 tens, so there must be 20 green counters. And now we've written this all out, we can check it with some different calculations. We could do 37 add 20 is 57 and check that that's right. Or we could do 57 take away 20 gets us to 37. All of those different ways you can do a calculation you can use to check. So you might get a question like that, in which case again a bar model is a really good way to just show what's happening. Okay, let's look at one more example. A crocodile is twice as long as a lion, and a lion is 3 times longer than a meerkat. How many meerkats would be the same length as a crocodile? Whoa, okay, a lot of information there. This is too tricky perhaps, or it might not be, but for most people, myself included, it's tricky to hold all that information in your head. But as soon as you draw it out as a bar model, it becomes more straightforward. Let's look at this first bit. Here's a crocodile. A crocodile is twice as long as a lion. Right, okay, we can draw that, can't we? So here we go. Here's a lion, and it's half the crocodile because the crocodile is twice as long as it. So we could fit one more lion all the way to the end, and it would be the same overall as a crocodile. Right, so we've represented that first bit of the question, that a crocodile is twice as long as a lion. Now let's look at the second bit. A lion is 3 times longer than a meerkat. So we can draw that in here. Look, here's our lion, and in the length of a lion, you can fit the length of 3 meerkats. Okay, well now we're getting somewhere. How many meerkats would be the same length as a crocodile? Well, we can see, can't we, that we would need one more lion to fill in this gap here to get us to the same length as a crocodile, and one more lion would be the same as 3 more meerkats. So there it is, there's our second lion, and that's the same as 3 more meerkats. So altogether, how many meerkats is as long as a crocodile? 1, 2, 3, 4, 5, 6. So can you see that by representing that in a bar model, we've made our lives so much easier? Now, obviously, if you were given this question, you probably wouldn't take the time to draw the animals. You'd probably just write crocodile, lion, and meerkat. But I've shown it here, so it's really easy for you to see what's going on. Okay, those are a few examples. Time for you to have a go at questions. So what we're going to do is I'll show you the question, I'll read it out to you, and then you can click pause, have a go, and when you're ready, you can click play and we'll go through it together. And we'll work through a few questions just like that. So here we go with question 1. There are 25 people in a room. 15 people leave at 1 o'clock. 9 people leave at 1:15. How many people are left in the room? So, have a read through of that question again. See if you can draw a bar model to help you think about what's happening. And then when you're done, click play and we'll go through this together. So click pause now and have a go. Okay, let's talk about this question then. How did you get on thinking about using a bar model to help you? This is what I did. There are 25 people all together in the room, so that was my biggest bar at the top. And we can ignore here the times that people are leaving. This is sometimes put into questions to try and throw you off and to try and make you think you need to consider it. But actually, all we really need to think about here are the people who are leaving. So 15 leave first, and then another 9 leave, and we need to know how many people are left. So that's represented by this little end bit here. How many are left in the room? And all we really need to do is add 15, add 9 together, and that will help us then work out how many people are left. So if you do 15 add 9, you get to 24. So 24 people have left the room. Now we only started with 25, which must mean that there is one person left. So this tiny little bit here, this remaining part that would make 25 altogether, is the one person left in the room. Okay, let's have a go at another question. Question 2. Peter is making pizzas. Each pizza takes 5 minutes to cook. How many pizzas can he make in 30 minutes? So have a go at this. Think about how you can use a bar model to help you. Click pause here and click play when you're done. Let me show you how you could have worked this out then. This is the bar model I drew. So I knew that I had 30 minutes altogether to cook pizzas, and each pizza was going to take 5 minutes. So I counted up in fives and saw how many I would need to make 30. Now, I've managed to make my parts quite even, but don't worry if your parts aren't quite even. It's not about your bar model looking perfect. Your bar model is there to help you. So if we count up in fives, we can see how many fives we need to get up to 30 minutes. 1, 2, 3, 4, 5, 6. And we'll just check that that makes 30 minutes by counting in fives. 5, 10, 15, 20, 25, 30. So altogether, you can cook 6 pizzas in 30 minutes. Okay, let's have a look at the next question. Faith buys 2 pieces of fruit which cost the same price. She pays with a 50p and gets 30p change. 2 questions then. How much does the fruit cost altogether? And how much does each piece of fruit cost? Have a think about how you can draw a bar model to help you. Click pause here and click play when you're done. Let's have a look then. I actually drew 2 bar models here. This was the first one that I drew. So the first question is what I started with. So Faith paid 50p altogether and she got 30p back because she'd paid more than she needed to. So this bar model shows that 50p is what she paid, 30p is what she got back, so this much here is how much the fruit cost. Well, I can use my number bonds here. I know that 3 and 2 makes 5, so 30 add 20 makes 50. So I now know that Faith spent 20p on her fruit. So the fruit cost 20p altogether. So then I drew another bar model. I drew this bar model. And you can see here it's the same as before with 50p as the total amount that she gave. 30p she got back, and that means that her fruit was this bit here, 20p. And I know that each piece of fruit costs the same amount. So I need 2 amounts which are the same, which add up to 20. And I can do that by just chopping 20 in half, and I get 10p and 10p. And I've shown that here on the bar model. Look, this is the part for the 20p that she spent, and I've chopped it in half, and each part now is 10p. So each fruit costs 10p. So you can see that we've worked it out step by step, but we've drawn a bar model all the way along to help us visualize, which means imagine what's happening so that the numbers don't get lost in our head. So hopefully you saw how you can use a bar model to help you. Maybe you did exactly the same as me, maybe you did something a little bit different, but hopefully the bar model was something that was useful to help you with your thinking. Okay, last question before our challenge. James has £5. Sim has 4 times as much money as James. Sim gives James a quarter of her money. how much does James have now? So have a think, work it through step by step. Even if you're not sure about the question, think about what you can draw to get you started. That might give you some ideas. So click pause here, have a go, click play when you're ready to go through it with me. Right, let me show you what I drew. So I drew this. I started off by thinking about James, because that's the first piece of information I get. James has £5. The next bit of information I get is that Sim has 4 times as much money as James. So I drew 4 lots of £5 just to show what that looks like. Here's James's £5, here is Sim with 4 times as much. Now I've drawn that, I can start thinking about the rest of the question. So Sim gives James a quarter of her money. Now what's really helpful is that because Sim has 4 times as much as James, I've actually already split Sim's money up into 4 parts, haven't I? And they're equal parts, so there must be quarters. So that's kind of handy, I've already done that bit. So if I was to take 1/4, so that's one of these parts, and give it to James, well, James would now have 2 £5. And that's simple. I just need to add those together then. £5 add £5 equals £10. So all of a sudden, by seeing what's going on in this problem, by drawing out a bar model, the problem becomes a lot more straightforward. If you didn't quite get that, don't worry about it. But maybe have a go now at drawing your own bar model and seeing if you can understand each part of the bar model, what it's showing. When you're done with that, we'll move on and do the challenge. Right, here's the challenge. This is one from way back in our Power Maths book. 19 more marbles are added to the green pot. How many more marbles are there in the green pot than the red pot now? Okay, so let's have a look at what we're being shown, because this will help us to understand this question, because we need to know what's going on here. We don't get much information. So we've got a green pot here and a red pot. At the moment, we've got 17 marbles in our green pot, and we've got 24 marbles in our red pot. And you can see that, look, the 24 bar is bigger than the 17. But now we're going to add 19 more marbles to our green pot. And you can see it's getting bigger because there are more marbles. Then we need to work out how many more marbles are there in the green altogether than the red. There's 2 parts to this problem, and you can use this bar model here to help you. So either draw that out again or use the one on the screen to help you work it out. Okay, click pause here and click play when you're done. Right, let's have a think about how we can work this out then. So the first thing we need to do is work out how many green marbles we've got all together. And we need to do that by adding 17 and 19. And altogether that makes 36. And we can see here that that makes sense, doesn't it? Because we've got more than we've got in the red. 36 is more than 24. But now we need to work out how many more marbles are there in the green compared to the red. So we're trying to work out this missing bit here. And we need to do that by either subtracting 24 from 36, so doing 36 take away 24, or we can count on from 24 how many do we need to get to 36. And the answer is 12. 24 add 12 more would get us to 36. So there are 12 more marbles in the green pot. Well done today on all your hard work on those problems. Even if you didn't get all of them right, well done for having a go at seeing how you can use a bar model to help you. We'll finish things there for now. Well, I hope you enjoyed that lesson on bar models. Well done for getting stuck into those tricky problems. Join me again tomorrow where we'll be having a look at another way of representing numbers and how you can use that to help you solve problems. I'll see you tomorrow.